So, hey folks, welcome to Cloud Native Labs, where we deep dive into the code behind Cloud Native. So, I'm your host, Shahryar Sake Mithul. So, in short, you can call me Mithul Shahryar. Okay, so I'm a sales of ambassador, so I'll be host tonight. So, every week we bring a new set of presenters to showcase how to work with Cloud Native technologies. So, they will build things, they will break things, and they will answer your questions. So, in today's session, I'm stoked to introduce Sebastian will be presenting on enabling self-service for developers using Kubernetes operators. So this is an official live stream of the CNCF and as such is subject to the CNCF code of conduct. So please do not add anything to the chat or questions that would be in violation of the code of conduct. So basically, please be respectful to all of our fellow participants and presenters. And with that, I will add Sebastian to the stream. Okay. So hey Sebastian, how are you?
Hey, hi, me too. I'm fine. Awesome to be
Yeah,
here. Thank you for the invitation. I'm really
yeah,
excited to be here. Yeah.
awesome. So yeah, it's awesome to have you here in the stream. So it would be great if you can actually introduce yourself, and then we can start our stream, right?
Oh, sure. So my name is Sebastian Blanc. I'm half French, half Dutch. That's why I have this weird accent. I'm based here
Uh-huh.
in France. I'm a developer advocate, so that means my job is to make developers happy. And
Uh-huh.
yeah, I have a slide giving a bit more about myself in a moment, and I
Yeah.
will be able to show you that. And yeah, and again, I'm happy to be here. It's been a long time since I did a live stream. I did a lot in the past, but
Uh-huh.
lately I was more on booth duty more than doing presentations. So I'm really happy to be here, especially
Yeah.
doing live coding stuff, and I love that. So yeah,
Yes. Awesome. Awesome. So yeah, let's get started with the stream then.
yeah.
Okay. Yeah, I've added it to the stream.
Yeah, awesome. Okay, so I can go. Okay.
Yeah, sure.
Okay, awesome. Hey, and I see in the chat there are some people. Hey, Alessandro, I remember you. I met Alessandro this year. It was great to meet him. I think I met him in London. Anyway, today we will be talking about enabling self-service for developers using Kubernetes operators. Okay, that's a lot of words, but don't worry. I will explain you exactly what we are going to do. Don't worry, I don't have that many slides. I will go quickly over the slides and then we will dive into some code, some live coding. Maybe things will break, as you said me do. Usually the demo gods are not really kind with me, so let's see how it goes. Let me go on the right screen. So my name is Sebastian Blanc. You can call me Sebi. You can follow me on X with Sebi2706. I have 20 years of experience. I'm a Java software engineer, also part of the Java Champion program. And as I said in the intro, I'm a developer advocate. So my job is to make developers happy. And how do I do that? By doing streams like that, by going to conferences, um, by creating content. But basically, my passion is to build relationships with developers from the community, from customers. That's what I love to do. Currently, I'm a developer relation engineer. So that's another word for saying developer advocate at Port. Port is an internal developer portal. Okay, even if it's not really the topic of this talk, I will explain you a little bit later why it could be nice to use a portal in combination with Kubernetes operators. Anyway, beside that, I love the game Half-Life. I'm a huge fan of this game. It's the best game ever. And I love cats. I have myself 5 cats, and you cannot see her. Maybe I will take my camera and show her. But Nala, one of my cats, is here. She loves it when I do live streams, and she's just here listening to me. She knows everything about Kubernetes, I think, since the time I'm doing streams. Anyway, let's get started. So before we talk about self-service and what it does, what it exactly mean, okay, let's talk about when there was no self-service. So when I started my career back in 2004, self-service was something that we never really thought of. And when a developer needed something, deploy a workload or have access to a database, how did it work then back in the time? Well, basically it was me sending an email, and that is really from back from 2004. I was working for a big insurance, and when we needed to have a new environment for testing, even for prod, for quality testing, I was basically writing an email to the one guy in ops, that could do that for me. So, hey, could you create me a new environment with for that too? Remember, we need to upgrade the GDK. The ear file is on this shared folder, and yeah, there's something wrong with bin.xml. Please ask Robert. He knows what to do. And I was sending the email and hoping that everything went well. Okay. Of course, I was receiving this kind of emails. I'm on PTO. Robert will be my backup during this time. So what do? I forward this email to Robert. Okay. Hey, Robert, please see the email below. Could you help me with this? Okay. And then Robert answered me, sure, I planned it for next week, Wednesday. So imagine we are Monday and he say he will do it next week, Wednesday. Also, I'm not entirely sure how to upgrade the GDK. I will let you know. Okay. And then I was just waiting 10 days to get my environment, and things were not great. I had to write a lot of other emails. That was back in the time. Then at one point we got tickets. Okay. So I opened my service now and I write a ticket. And the thing was, it was a bit better because you could trace the ticket could have a status, but still on the other hand of the ticket, there was a human. And things could take some time and we could run into exactly the same issues as when we were exchanging emails. And to be honest, that was not really a big deal because back in the time we had one big monolithic app that was deployed maybe twice a year. We, as a developer, we didn't really need self-service features. We were just focused on the code, and yeah, that was it. But things change. Okay. Yeah. And just to remind you, back in this time, we had really silos between project owners, developers, sysadmins, and ops. We had really walls behind that, and we were just dropping the stuff from one wall to the other. But again, it was not a really big issue because we had one big app to handle. But then IT started to change. We started to move to the cloud. Amazon was one of the first with AWS. They realized that they had a lot of computing resources that was not used all of the time, and they say, "Hey, what if we could rent that computing time to other people?" And basically, that is how cloud computing started. Okay, so that means also it was way easier for any company to request to have computing resources. And in the same time, something else happened. We embraced distributed computing. We call it also cloud native, but in the end, it's just distributed computing. And one of the biggest change was instead of having one big monolithic app, we started to split that in smaller services, hundreds of services, what we call today microservices. And so you can imagine that now as a developer had way more requests to deploy all those services, having requests to a database that is running in the cloud to connect one of my microservices there, asking to scale up, and doing that brought a lot of cognitive load on the developer. Okay, um, and then we had containers. Okay, that started to help the developer because in the beginning you could say, hey, it works on my machine, but it was not working on prod. Yeah, because I was on Windows and the prod was, I don't know, on a Solaris system. But things helped. Things went better for the developer when containers appeared. For the developers, it was easier. For the ops team, it was not that easier because still had a lot of containers to maintain. And yeah, still we had a lot of requests. Okay. Then slowly new practices and methodologies appeared, and the most famous one is DevOps philosophy, where we try to break those walls between all those different teams. And those things helped also a lot. But at the same time, the developer that was just focused on coding and that was all he was doing, suddenly we also asked him to take care of stuff like observability and even ask him to deploy his own stuff, maybe not in prod but in some environments. So there was a lot of stuff that he had to learn. The promises of DevOps was continuous delivery, self-sufficient developers, quality, security, compliance at scale. Okay, and this one in the middle is really important because how can you make a developer self-sufficient when he has to deal with so many things beside coding his app? Okay, um, developer, he has to code, he has to deploy, he has to manage incidents, he has to comply with the standards, with security, a lot of things, a lot of cognitive loads. So basically, what does it mean for a developer today to create a new microservice when he starts a new project with his team? Okay, you need to create a new GitHub repo, generate some security tokens. Apparently, they will be storing maybe some stuff in an S3 bucket. There's code review. He has to deploy, and finally, it has to go to production because until your code is not in production, your code doesn't exist. Okay, so again, a lot of stuff to do to manage, and we could do that with tickets. The developer could write tickets the whole day long to the ops team, but the ops team has other important things to do, like preparing the VMs, making sure that everything runs smoothly, the network issues, etc. That's the job of the ops team, not handling those really demanding tickets from developers. Okay, so how can we offer a unified self-service experience to developers in the world today? So from here, I will assume one thing. It's and something really hype lately is platform engineering. Okay, so where companies tries to build their internal developer platform, and that's great. That is really the way to go to make your developers self-sufficient. Okay, Um, but you need a base platform for that. You could build your own. A lot of companies does that, but it's really risky. I start with the assumption that if you start to build your internal developer platform, you should take as base platform Kubernetes. Why? Well, because it's for me, Kubernetes is the operating system of the cloud native world right now. Okay, it will take care of your deployment, scaling, monitoring, repairing when something goes wrong, securing. Kubernetes offer all of this. Okay, so basically, you declare a resource. The developer declares a resource. I want to deploy that. You apply that to the cluster, and the cluster makes sure to create all the resources and to maintain them, to schedule them, to put them in the right nodes, etc. It's really a nice piece of software. I'm a huge fan of Kubernetes, and I really love it. So people say a lot that Kubernetes is a container orchestrator, which is true. But for me, there's one other feature in Kubernetes. Well, there are a lot of features in Kubernetes, but there's one even more important feature in Kubernetes. And this feature is the Kubernetes operators pattern. Okay, we will take some time to explain what it is. Basically, in Kubernetes, you can define custom resources. You can extend Kubernetes with the API that you want, that you decide. There's no limit. Kubernetes can accept a resource of the type custom resource definition. Okay, if you are a developer or a Java developer like me, it's like a class definition, and you can apply that on your cluster, and your Kubernetes cluster will understand this, this type of resource. It sounds really simple, but if you think about it, it's huge. That means that you can benefit from all the basic building blocks and the power of Kubernetes while providing your own resources. Okay, of course, defining a resource is not enough. When this resource is applied to your cluster, something needs to happen, and that will happen with a custom controller. We will dive into that in a few minutes as well. But the combination of custom resources and a custom controller, that is basically a Kubernetes operator. Okay, basically to replace a human operator. It can install, upgrade, it can migrate. Um, in the end, there's no real limit of what an operator can do. So again, operator is the wedding in heaven of a custom resource definition and custom controller. That is a custom controller. And you extend the Kubernetes API by defining a custom resource definition. And in a few minutes, you will see it live how it looks like. Once you have that, you can start building your custom controller. And what will your custom controller do? It will do one thing. Remember, I told you, you declare a resource that you apply to your cluster, okay? That is the desired state of your resource. And your controller, he will make sure that the desired state is the current state in your cluster. That's all he does, okay? If you made I don't know, an operator that make a deployment with 3 replicas, and for some reasons, one replica goes down, the controller will make sure, okay, to spin up a new pod so it corresponds to the desired state. Okay, so that is his job. It's a loop. He's constantly monitoring all the resources, okay, and make sure that the desired state matches the current state of your cluster. You know what? Let me show you. Let me go back here to my. So how can you build an operator? Okay, the first part, creating a custom resource definition, that is really easy. It's some YAML, okay? But we will see that you don't need to write YAML depending on which SDK you are using. But in the end, it's some YAML that you apply on your cluster. That's easy, that's generic, that doesn't change. How do you build your controller, your custom controller? In the end, your controller is just a pod, okay? So what you put in your pod doesn't matter. You can use whatever you want. A lot of people think that to build a Kubernetes operator, you need to build it with Go because, you know, from the history, Kubernetes was built with Go. The first operators were built in Go. But if you would like, you could build your custom controller using Bash. I even saw some controllers written in JavaScript. So, but anyway, I'm a Java developer, and today what I'm going to show you is that you can also build your Kubernetes operators with Java. Okay, and one of the most famous Java operators that I love is one of my preferred operator is Streamz. So Streamz is basically an operator, as the name suggests, to have Kafka and Kubernetes in a few minutes. Okay, basically it provides you some custom resources like Kafka topic, and you just applied it on your cluster, and your operator will make sure that you have a Kafka cluster running, the creation of topics, and this is a pretty popular operator, which is, by the way, a part of the, let me see here, it's part of the CNCF, okay? And this operator is written in Java. So it took some time, but Java a few years ago decided also to create its own Java operator SDK. And today we have a really, really nice SDK because it could learn a lot from the Go SDK and not make the same mistakes that Go maybe did in the beginning, and even provide some extra stuff on top of it. And that is pretty huge when you think about it. I love Go, of course, but I love Java, and I know there are more Java developers in the world, especially in the enterprise, than Go developers. And when we speak about DevOps, one of in the DevOps philosophy, we ask developers to also be in charge of creating tools for the ops, making sure they can deploy their own stuff. So if the Java developer, the existing Java developers of a company can start writing operators for their infrastructure, for their base platforms, or for their internal developer platform, that is huge. So we have an SDK. Okay, this SDK is also an incubating project of the CNCF. So and it's sponsored by great companies like Red Hat, and sorry, and using this operator SDK, it's really, really easy to create your own operator, and we will create one really simple one from scratch in a few minutes, and then I will show you a bit more complex operator, but just so that you get the whole picture. Okay, one more thing, I could use plain Java to use this SDK, okay? But I'm going to use a Java stack. I could use Spring Boot. I could use Micronaut. I will be using another stack. It's also an open source project. It's also part of the landscape of the CNCF. It's called Quarkus, which is a Java stack to make sure that your Java apps are fast, not so consuming in memory, and focusing on developer experience, on developers' joy. Believe me, if you never tried Quarkus, try it. I've been using it for 4 years now, and every time I use it, I really have this joy, this developer's joy. Okay. So anyway, you know what? Let me go to yeah. Let me go here. No, let me open. I got a terminal here, and let me go. I think I created here a CNCF Live. Okay, let me increase a bit the font. And what I'm going to do is create a new operator. And for that, I'm using the Quarkus CLI. Okay, so I could also use Maven directly. It's up to you, or any IDE. And let me see here. Let me change the name here. Let's call it CNCF Live. Okay, and here I say I want to add the Quarkus operator SDK. Okay, that's just a shortcut for the name of the extension. The extension is just a jar. It's just a dependency that I add to my project. But just by adding that, I will my app will know that it has to behave like an operator. Okay, so let's go. There we go. It has been created. So let me go into this. Let me show you how it looks like. Oh, I don't have tree installed. It's a new computer. I forgot to install it too. But basically, if you use to Java project, it's basically a source file, a source folder, and a POM that defines all my dependencies. And you know what? Let's just go here in VS Code and let's open a new window. And I will open this new project that I just created. It's over there. Don't worry, I will increase the font in a few. Let me show you the POM. So if you are a Java developer, you might know what a POM is. Okay, if you don't, it's like the manifest of my Java project. And the important thing to see here is that it has a dependency on the Quarkus operator SDK. Okay, and Java is empty for now. I don't have any properties. And what I will do is start my operator, but locally. I don't need to package it and deploy it in a cluster. I can just run it locally. So let me go here, open a new terminal. Let me move that over here. And we will be using a Minikube for now. Later on, I will be deploying on a real cluster. Let me update the context just to be sure. Current context, okay. Let me just make sure because I've been doing a lot of, yeah, that's the right one. Okay, there we go. And what I will do here is Quarkus run. Let me see, Quarkus dev. Okay, Quarkus dev. That will compile my app and run it in dev mode. Let me just remove this. Let me not update my IDE now. Could be funny, but I'm not. I'm not going to do that. And what I'm going to do here is the first thing. Remember when I told you to create your operator, you need to create a custom resource definition. Okay, that's some YAML file that in the end will be applied to my cluster. What I'm going to do here is to create it directly from my IDE. And I can do that by using this. And here, oh, I just realized if I do clear, maybe it will come up. No, it's hidden by, let me see. So that's not a problem. So Quarkus, here I type Quarkus. Let me just, maybe I can hide this one. Yeah, there we go. Okay. Quarkus, and I will say API. So basically, I want to create an API. Sorry. Quarkus operator SDK API help. Okay. So here it's that's what I type here. Quarkus API. So from here, I can create a new API for my operator. So let me type Quarkus operator FDK with the kind. Sorry that you missed some of the part here, but the kind. We let's give it a cool name. Let's call it live stream. Okay, live stream. And then I will give it a group. The group will be sebi.io. And I give it a version here. That will be one beta 1, something like that. Okay, there we go. What did I? Kind is unknown. Life option kind is unknown. What did I do? What did I do? I told you the demo gods are not really great with me usually. If I do dash q, okay, would that work? This okay. So he decided to play with me. Don't worry about it. Okay, let's do it again. That is what I did just before. Great, it has history. Let's call it live stream. There we go. Okay, there we go. Sorry, I don't know what happened. Demo God's playing with me. But anyway, it has created some Java classes for me. And let's take a look at this. First of all, it has created for me a new custom resource, which is called live stream. You can see here it extends custom resource, okay? And my custom resource has a spec, like any Kubernetes resources, and it has a status. Okay, and it is namespace. It's not really that important. And then we have the reconciler. That is my custom controller. Basically, here in this part of the code, okay, here is where I implement my logic of my operator, like creating other Kubernetes resources, deployment services, ingresses, secrets, or anything else. It could be a call to an external API. Really, I can do whatever I want. That's what makes operators so powerful. And here I got my live stream spec. So here is where I can define really my API. Okay. And here I have a Copilot that suggests me some stuff, but maybe we won't go with that. But let's do a private string and call it title. Okay. I want something like title. And then I want the getters and the setters, okay? And here, that's great. Here, Copilot is helped me a lot because I'm lazy. Okay, let's keep it really simple. My live stream spec, my live stream resource will just have a title. Okay. From here, what I can do, I can tell my project to say, hey, you know what? You should apply this CRD to my Kubernetes cluster. Okay, so let me try to do that and let's see what happens. So here I can go back to the console, quit, let me see. And at any point here, it should generate for me, if I go to the target, Kubernetes, there you go, you see, it has already generated for me a custom resource definition. Cool. So that's great. You can see here it recognizes here the title that I defined. It's a string. That's super cool. That's YAML that I don't have ever to write. Okay, so I'm happy with that. Let me open another screen here and let me do just make sure I'm in the right context. And let me do a kubectl get ctrd. Let me retrieve all the existing custom resource definition that I have. So that is one that I will show you later. That is one me earlier today when I was rehearsing my live stream. And that is the one we just created now. Okay, so if I do a kubectl ctl describe crd live streams, okay, I got here the description of my CRD and I got my title here exactly as I want. And remember, my app is just running locally in dev mode. And I can do crazy things like going back here to my spec. And let me go here, for instance. And let's imagine that I want to add another field like replicas, okay? Imagine that in the end, my app will, why he's not happy? Oh yeah, because I didn't put a semicolon. Okay, maybe I will create some deployments at one point, and I want to set the replicas. So let me create here this getter, and let me create the setter. And here I will just hit save, okay, and wait a few seconds. And the app should take care of that and say, okay, you apply the new one. And if I go back here and I ask him to describe my live stream again, if we go back here, we should have now replicas, okay? And that is already available on my cluster. So when I told you developer experience, that is huge. That means that I can work on my operator, changing the fields, and it's directly applied on my cluster. It's really a great feeling. Let me just decrease a little bit because it's really big here and I don't have any place. Okay, so that also means that I can create, if I want, a new resource of the type live stream, even if it will do nothing, because if you take here a look at my reconcile loop, my custom controller logic, nothing is happening. But still, I can do that. So if I do touch my resource.yaml, okay, and it should be appearing here, my resource YAML. Let's create API version will be cb.io, and it's 1 beta 1, I think I called it. And then I have the kind. The kind will be live stream, okay. And then the metadata, the name, my resource live, okay. And the spec, will be the title, my live stream, and replicas, okay. I was hoping for Copilot to be really smart. Okay, there we go, Copilot free. Okay, so imagine that is what I have created, and I should be able to do kubectl apply -f my resource. Okay, there we go. Live stream not match kind live stream in version cb 1 beta 1. Okay, so I made a small mistake here. Let me just be sure. cb.io v1. I forgot the v. that's a thing. So let me go. Yeah, thank you. Someone saw it. You know, when I'm and my cat, yeah, the cat is moving a lot here. Hopefully she won't go on the keyboard of my laptop, otherwise we're in trouble. Anyway, let me apply that again. It's been created. That's cool. If I do a kubectl get live streams, okay, I got it there. My live resource live, it's there. I can delete it, update it, do whatever I want. But yeah, for now, it's pretty useless because it doesn't do anything. For that, I need, of course, to implement the reconciling loop, okay? I won't spend too much time here, but I just want to show you. So basically, here I do my complicated logic and reconcile the resource, okay? And what we are going to do is have the status here, and let me just implement the status. I do a private string status, okay, there we go. And let me do the getters, get status, there we go, and the setter. Cool. And let me also add a constructor, okay, and he's smart enough to provide me this constructor. There we go. We go here and we say, hey, let me create a new status, okay, live stream status ready. Okay, I love Copilot when he suggests great things like that. And then I take my live stream resource, so the resource that I applied, and I can say resource set status, set the status, okay? And here, instead of doing update, no update, I say update status of my resource. Okay, so let's try it again. Let me see. Let me change something to my custom resource, for instance. Let's go back here, and let's say, let's just add this, okay? And I do a kubectl apply apply my resource. Okay, it has been configured. And if it goes as planned, I should have a lot of red here. Let me see. Hopefully has, yes, I have a lot of red. I have a lot of red. And that is totally on purpose, just to show you how cool it is to be in live mode. So basically, I won't tell you everything, but he's complaining here that my live stream status doesn't have an empty constructor. Okay, so let me just add here an empty constructor. There we go. I save that. By saving it, it should reload the app. And I shouldn't have any error here. Cool. And if I do a kubectl get live streams, and how did I call it? My resource. No, my resource live. My resource live. And I want to have that in YAML, for instance. Look at this. Now I can also set a status. Okay, just again, my operator here doesn't do anything special, but it was just to show you how easy it is. And of course, this SDK come also with a library called the Kubernetes client. Like you have the Go Kubernetes client. I don't remember his name, but we have a really good Kubernetes client to interact with your cluster. To create your resources. It's using the builder pattern. I will show you that in a few moments. I will show you that right now, by the way. So let me stop this app. Stop me. And let me go to a bit more advanced use case, okay? Because here we are doing nothing really special. Let me go back to... Oh, yeah. I have a really small, small diagram. Let's imagine that we want to create a new custom resources called exposed app, and look at the YAML that we will provide. The developer will just have to provide this YAML. It's 6 lines of YAML, yes. And what will happen under the hood? What will the operator do? He will create a deployment using the image reference. Okay, he will create a service to expose it, and then he will even create an ingress. Imagine all the YAML that you need to write yourself if you want to do that yourself. Here we will implement all this logic in the operator. Okay, and let me show you how it looks like. And by the way, what I'm showing you here is one of the samples included in the operator SDK when you are using it. On GitOps, there's a folder samples, and one of the sample is this one. CMCF Live, that's the other one. Let me go. Let me just find, I'm a bit messy in all my, there we go, this one. Okay, so expose app, just like before, it extends a custom resource. Okay, here we have some helper methods. You don't pay too much attention to that, but let's take a look at our spec here. Okay, so expose app, it will have an image ref. Eventually, we can provide them with a map of environment variables and the name of the endpoint for the ingress. Okay, but that is not mandatory. We will just play with the image ref here. And of course, we have the getters and setters. Of course, we also have a status. This status will be quite useful because it will show us, once the ingress is resolved, it will show us the host in the status. So if you describe your custom resource, you will also directly see in the status the host where your ingress is running. Okay, there's some logic to do that. Anyway, that's cool. Let's take a look at the reconciler. Let me take a look here at the different annotations. So here I can provide some configuration for my custom controller. We can ignore the beginning. What I want to show you are those 3 annotations here. Dependent. Here I can tell my controller that when there's a custom resource coming in, my exposed app, there will be 3 different dependent resources that needs to be created. A deployment dependent class, a service dependent class, and an ingress dependent class. Okay, and basically I just have to provide those 3 classes, and the magic of the SDK will make sure that those resources are created. Let me take a simple one here, the deployment dependent. So basically I create a new class that I extend from CRUD Kubernetes dependent resource. Okay, and it will be a deployment, and it is attached to exposed app. And look at the name of this method. I love it. It's called desired. That really corresponds to what I told you in the beginning. You have a desired state, and the operator makes sure that the desired state matches the current state. That the current state matches the desired state of your resource. And here we are using the Kubernetes client that I told you. Basically, we are using here a deployment builder. I'm creating my deployment resource, and I'm taking here the image ref that I take from the spec from my custom resource. Okay, I do some stuff, but basically that's all I need to do. Okay, I do the same for my service. Okay, I have also this desired method that I need to implement. So here I create a new service, and here I create a new ingress. And just by doing that, and yeah, there are some extra methods, but I don't want to spend too much. Let me do a time check. Oh yeah, we are already late. Okay. Just with that will make sure that when I apply my really simple, oh, if I'm clicking on the screen here as well, if I just apply this, okay, it should create for me anything I need. So let me go back here. Let me sure I'm on the correct Minikube. There we go. Let me clear. Let's change the name as well. Let's call it Hello CNCF Live. Okay. The image ref here is an nginx. Okay, it could be any image that you want to deploy. And then I will say, okay, I want to apply. It's in the target? No, it's in source, main, resources, and it's my app YAML. There we go. It has been deployed. Cool. Let's make sure it's there. So if I do get exposed apps, I can see it here 9 seconds ago. You can see that was my trial earlier today, but it's there. Cool. And this should have created for me also a deployment. Okay, let's make sure I have. Oh, it hasn't created for me the deployment, so that is interesting, or it's not still there. It's not yet there. I told you, demo gods are playing with me. Hello, Crocus. Let me see what happened. kubectl describe exposed app, and I call it, and it's my Hello CNCF Live events. It should be. It doesn't have a status. Not sure what is happening here. Doesn't really. It's not a really big deal. You have to believe me on that. What I will do, I will delete the previous one. Delete exposed apps. Hello, Quarkus. Okay, and I will delete also the CNCF live. There we go. Okay, and let's try it again. Please work. Okay, let's call it this one, and let me apply this one. Cubans, let me just make sure I'm in the default namespace. Yes, should be good. I'm not sure what is happening here. Source, main, resource, app. There we go. Okay, this one is created. Come on, now it's time to make me happy. Okay, looks like my cluster is having fun with me. You know what we are going to do? We are going to deploy that on another cluster. kubectl, let me do that. So here I'm using another cluster running on Cyvo. I don't know if you know Cyvo. It's super great to have clusters that are not really expensive. Config. let me use context. Yeah, let me use this one. Okay, kubectl get pods. Let me make sure, yeah, I'm in a good one here. And let me do my apply again. There we go. Okay, and now get. Ha! Thank you so much. He has the answer. I forgot one crucial thing. So,
Yeah.
you know what happened? I should have an error that the CRD didn't exist. But since I'm reusing a minikube where I already applied that CRD, you're totally right. Thank you so much. Thank you so much. Cortex dev. Yeah, I need to run my controller. I need to run my operator. Otherwise, the magic cannot happen alone. Anyway, it doesn't really matter. Now I'm on the other cluster. Thank you so much, Eric. Was that? Yeah, yeah. Thank you so much. Let me see, and it should reconcile. By the way, it should now. Let me see. Yeah, there we go. So there we got it. Hello, CNCF, please work. I should have my service as well. Okay, I got my service, and I should have my.
Sebastian, can you zoom in a bit because I see some comments about the 180p.
Okay,
Okay.
yeah, better here. Let me just hide this again. Whoa, better. so
Okay.
so I get here my ingress with the address. Okay, I got everything working, and the great thing with declaring those resources as dependent, that means that if I do kubectl delete exposed app hello syncf please work. Okay, work. Okay, I delete it, but that will also delete for me. You can see I don't have anymore the ingress. I don't have anymore the service. Okay, it has been deleted for me. So it deletes everything for me as well, which is great without having to implement some custom logic here in the reconciler, making sure that when I delete something, all the dependent resources are deleted. So that was just to show you how great this operator SDK for Java is. If you're a Java developer, please take a look, play with it, use the Quarkus extension if you want, or use the Spring Boot extension if you want. Doesn't really matter, but that's it. Let me take the 12 last minutes to show you something else. Okay, so because now you have your operator, that's great. Um, Here it's running locally, but in the end, of course, you will just build it. That will create an image for you. You push it, you deploy it on your cluster where your operators run, and yeah, that's how things goes. Let me just go back a bit to my slides. There we go. One quick mention for one project that I love. It's an open source project, by the way, as well. It could be that at one point you have not one operator, but 10 or 20, 30 custom operators, which is nice because it makes probably sense for each of your teams. But maybe you want to streamline that for your end users platforms, okay, that are using the operators. And there's a project called K8s.io, okay, open source project, where you can compose your different operators. You can put them together and create a facet, which is an other custom resource. And basically you hide all the complexity for your users. You could write an operator that operates your operator, which is also a valid use case in some cases. But if you want to rely on an open source project with a great community, just take a look at K8s.io. Maybe one day I will do a joint live stream together with the people from Syntasso, the company behind it. But I love this project. Just wanted to mention that. But how do you make your self-service available to your developers? Okay, because in the end, it's about self-service. Well, direct access to the Kubernetes cluster, like I did here before, kubectl apply my custom resource. My potential dangerous custom resource. The thing is, do you want to give access to your developers to your cluster directly? Do your developers have kubectl installed? Do they know about kubectl or kube control? That's another debate. But anyway, I say kubectl. Um, no, maybe that's not the best way. Okay, so probably what is the best way to do is to have a GitOps approach. Okay, so because Git, that is a command that every developer knows how to use and has on his computer. Okay, so you should go for a GitOps approach where your source of truth is in Git. You create your custom, the developer creates his custom resource. He applied it to a specific Git repo, and then you have a GitOps tools like my preferred one is Argo CD, picks it up and applies it on the cluster. You should always strive for that. Okay. Um, yeah, just some stuff about GitOps. Git is a single source of truth. The great thing, you treat everything as code. You can revert, you can create pull requests, all the power of Git, and your developers know how to use that. Okay, so that should be the way how you provide, how you make your operators available to your developers so they can self-serve. It's basically creating my resource from my IDE and doing a commit to a Git repo. And a few minutes later, I get my app deployed. I get the access to my managed database, anything what your operator can do. But maybe when you create an operator, you create a new API and you expose everything to your developer. Okay, it could be that you expose some fields like a region where you want it to be deployed. Maybe that's something that you don't want to expose to your developer, or you want to streamline the regions where you can deploy that. And maybe you have some developers or some business analysts that also want to do self-service and they don't know how to use Git. So how could you manage that? Well, basically using an internal developer portal, which is the really a great complement to your internal developer platform. Okay, and where you probably your developer just log in into the portal and he has some actions cards where he can request stuff, a bit like ServiceNow, but instead of having a human at the other end, it's maybe a GitHub action or I don't know, any automation tool that you have, and you can connect those all together. And that is should be the right place to provide your operators, your custom operators. Okay. Um, Basically, developer, he creates a microservices from his portal and basically he can run in production. Okay. Um, Portals, you can build your own portal. Okay, that's I know a lot of companies that build their own portal. Most of the times they regret it after because the people that built this portal left the company and they cannot maintain it anymore. You can go for open source solutions like Backstage. Be aware that you have to manage it yourself, or you can go for managed solutions. I don't want to focus too much on that because, yeah, again, it's a community stream here. But we are working on the portal, and just to show you how it could look like if you're using Port, exactly the same app that we use here, the Expose app. I've created earlier today an action card here. Okay, so you can see that I do a lot of fun stuff. I can also deploy quake-free servers and stuff like that. But anyway, what I did basically in my portal, and that is a concept that you will find back in any other portal, you have this concept of blueprints that describes resources. And here I could generate the resource that reflects my CRD that I applied on my cluster. I could generate here a blueprint in it in my portal, and you can see it back, image ref, endpoint, namespace, whatever I want. And from that, I can create self-service action. And if I go back here and that I say, hey, I want to create a new exposed app, let me zoom in a bit, and I will create again an nginx and live from portal, okay, in the namespace default. But here I could streamline, I could hide the namespace and make sure they always deploy that in the namespace that I want, or always make sure some set of environment variable are there. I can craft that exactly as I want. I do execute. What happens here behind the scenes? I'm just calling here a GitHub action that should appear in a few seconds. There we go. Okay. that will call a GitHub action that will take the payload from my portal, create a custom resource of it, apply it to my cluster, or if I did it in the right way, make a commit to have the GitOps approach. But here I'm taking a shortcut. It's just applying that to my cluster. Okay. And let me see how far we are. Completed job is almost, oh, I think it's done. Okay, so that's cool. So if I open here and I say kubectl config, I go, no, oh, that's funny. Is that better? Yes. Okay. And if I do kubectl get exposed apps, I should have here my live from portal that I created 40 seconds ago. Okay. And that is even nicer. Here, I'm really providing a full developer experience just going through my portal. Okay. Of course, here I've created one, but I could also have day two operation. So I could update here my expose apps if I need to add some environment variables or even change the image reference. And of course, I could also do delete. Okay, so that was to conclude. Do I have some conclusion slides? Yeah, just overall for portals, you should have software catalogs. Oh yeah, that's also I forgot to show you that. Once I've created that, I could see here, I could have a new type in my service catalog of, hey, that's my live portal, that's my live demo. And from here, I could also directly update it, delete it, get some details about it. Okay, 2 minutes ago, the image ref, everything I need. So that should be stuff that should be part of your portal. Whatever portal you pick, okay, you should have your software catalog, your self-service actions. That's what we focus on today. Scorecards, airbag, of course, you want to limit who can do what, okay, and even some workflow automation. If I create an exposed app, maybe that should trigger a workflow automation that sends a message to Slack or whatever. Okay, so these are the main components that a portal should have. And conclusion, connective load of developers has increased a lot. Kubernetes should be your base platform. Custom resource definition are the core of your domain that you want to expose as self-service action. Building your own operator is not that hard. I built one from scratch, okay, and I showed you another one which was not that complex, but that did a great of things. Consider composing your different operators, like with K8s, or even by building your operator that operates operators. GitOps is the way, okay? And consider integrating an internal developer portal to remove any remaining friction or to streamline and to offer the best experience to your developers. That's it. Thank you so much. And I'm just in time, 1 minute before time. That's awesome.
Yeah. We just 1 more minute. But yeah, we are here to take questions as well, like if folks have any questions. But I think Alessandro has some question, like if we have any repo for that, to share and
Oh,
follow along the thingy,
um,
what
yeah.
we
So
did today.
yeah. So what I could do is share the. I will share with you, and I will put it. I'm not sure I can paste it, but you can probably do it.
Yeah,
Um,
you can just share with me. I can just
yeah,
paste that out, no problem.
yeah. So I will share this repo, and this repo here, that is the operator SDK, but it contains this sample folder with the exposed app. That is exactly what I showed you. So that could help a lot.
Yeah,
Let me put
sure,
that in a private chat for you, and you can put it
sure.
in the chat because I think I'm not allowed to put to paste anything here.
Okay, great. I believe folks can now check that out. Okay,
Okay.
great. So yeah, that has been resolved. If any of you have any questions, feel free
Yeah.
to share right now. Also, like talking about the stuff. So you were mentioning about like how it manages like especially the issues with like Java being the consuming a lot of memory, right? So
Yeah.
okay, so other than that, like where should the source of truth of CRD live? The YAML or the code? If
Yeah.
that's
That's a big
faster.
question because you could see here I started from the code,
Hmm.
but the entry point could be also a team defining an API, and
Hmm.
and that generates an open API spec, and that could also generate then the CRD. But some teams might prefer using code, or some teams might prefer starting directly with YAML. So I think it should. Yeah, it's always the same answer. It depends. I think I like the code approach because yeah, the team is creating a new API, and he can best define its API through code, and that will generate the CRD in the end. Yeah.
Yeah, great. So I guess we have Can
Oh, awesome! I love
Silva.
to read it. Yeah.
Yeah, you'll introduce it to Steam. Okay, great. Okay, let me remove that. Okay, so okay, we learned about like operators pattern today. So other than operator patterns, what are your preferred CSS projects?
In the CNCF landscape. So I
Mm-hmm,
have my preferred one, which is Knative, which is the
mm-hmm,
serverless native solution for Kubernetes. It's a fantastic project where you basically it's also it's come as an operator, and where you can define your service just pointing to an image, and it will
mm-hmm.
create everything for you, the deployment, the service. It will scale down to zero. You can do some splitting traffic. So it's really a project that I love. There's also the whole eventing part of Knative that I love, and next to that, I would say, well, I also love Istio, the service mesh project. Those two projects are, yeah, projects I worked a lot with when I was working
Yeah.
for Reddit back in the time. But those two projects are really nice project, and of course the Java operator SDK.
Yeah. Okay. Okay. So we can't see any questions in the chat section. I believe. Mm, okay. We can end our session today then,
Okay.
Sebastian.
Hey, thank you so much. And if anyone has
Yeah.
questions, I shared my. You can follow me on Twitter, and yeah.
Yeah, sure. So thank you so much, Sebastian. So it was an awesome time, like being with you. And also, we had some few problems in the terminal, right? We initially solved it, right?
Oh
Folks
yeah,
were
I
very
love
interactive. They
The
helped
audience
us.
solved my issues, and I love when that
Yeah,
happened because I'm a bit stressed and I forgot things. And that also means that people are paying attention, and I love
yeah.
it so
That
much.
that
So
was really
thank you.
awesome. Yeah, every
That's
time
the
like
power of
talking
the
about,
community. Yeah,
yeah, starting from V1 beta and again the
yeah,
controller. So both of the issues they were solved.
yeah,
Okay, so that was very interactive for all of us. So learning curve. So yeah, thank
yeah.
you so much, Sebastian. And
Thank you,
yeah, with that we end our session. So thank you so much. See you soon.
thank you, everyone. Bye bye.
Okay, folks. So thanks everyone for joining the latest episode of Cloud Native Lives. We enjoy the interactions and thanks for joining us today and hope to see you in the next stream.